I can always hear your voice. Here we are. Day 2 of max-min problems. So we're just looking at another max-min problem, but on steroids. The steps are the same. It just might have a little more steps. Okay. So page 4 of chapter 4. We're going to start with the same way we started yesterday's problems, or Friday's actually. And yeah, so let's look at this. An open top box, rectangular cube, must have a square base and a total surface area of 3,600 centimeters cubed. What is the largest possible volume for such a box? So the first question is, what am I trying to maximize? Volume. What's the largest volume? So the first step is, I need a formula for volume because I'm trying to maximize volume. Whatever we're trying to maximize, that's what we need a formula for. Now, this box, what do we know about this box? We know it's surface area. What else do we know? Open top. What else? The bottom is a square. So what do we want to call the bottom if they're both the same dimensions? Let's call them x's, sure. And we'll call our height h or y. I'm going to use y. You can, anything you want.
It's a rectangular cube. Oh, so that means the bottom is a cube.
The bottom's a cube. Okay, so we want to maximize volume. So what's our formula for volume? X squared y. Good. Now, in our max-min problems, we need to only have two variables. The one we're trying to maximize and one other. So we need to either get rid of x or y. So there has to be some information given, Landon, to get rid of x or y. What is that information that they gave us? Landon. Total surface area. Okay, so because we need to eliminate one of our variables, we're going to use our surface area. What's our surface area? 36. Okay, so 3,600 equals what? Well, we need an equation for our surface area. So x squared, either 2x squared or 1x squared. Just one because it's an open top. No, it's the outside when we do surface. Okay, so it's just the outside. Just the outside. Okay, sorry, I should have specified the outside, the surface area of the outside. Okay, what are the dimensions of all these rectangles? X, Y, and how many do we have? 4 of them. Okay, so we can either solve for X or we can solve for the Y's. Who's probably easier? Probably Y. Because we have two x's in here, right? Separated. So let's make it y equals. So subtract the x squared, divide by 4x. And that is our y. So now can we make our new volume? Yeah. So volume equals x squared times 3, can we simplify this a little? Oh, that's what I did. Yeah. Okay, so 3,600 minus x squared all over 4x. We're going to simplify this first. So tell me how I can simplify this. You can cancel out which x? Here? Yeah, you could do that. So this could be just an x. This one can reduce out. No, because it's a binomial, yeah. And then bring in the x. Okay, so that volume equals, recording. So what's 3,600 divided by 4? Or we'll just keep it all over 4 for now. And then we'll simplify it in a second. So we're not doing too much. Minus x cubed. Okay? So we just canceled out this x with this x, and then brought in the x squared, or the x, sorry, not the x squared. Okay, let's divide both by 4, so we don't have to deal with the constant on the bottom. What's 3600 divided by 4? Because we reduced out the x from there. Yeah, but it only goes into the numerator, not the, right? Okay, so 3600 divided by 4 is 36 divided by 4. 900. Yeah, so 900 minus x cubed, or 1/4 x cubed. So that's a little nicer. A few ways you could have simplified that, but now are we ready to derive? Yes, we just have two variables. Looks pretty. There's nothing else we really can do. So let's derive. With respect to what variable? X. Yes. dv dx is equal to 900 minus 3/4x squared. Good. And what else do we know for maximizing our volume? dv dx is 0. So can we solve for x? Sure can. Okay, so I just brought the 3/4 x squared to the other side then. So 900 times 4/3. So that would be 1200. Oh, this is ugly. Too bad. We're going to keep it as an exact value. So square root of 1200. We need to simplify this guy. We can break it into 400 times 3. Yeah, we're dealing with an application, so negative in this case. Otherwise, yes. All right, so we can do 400 times 3, so that could be 20√3. Square root of 400 is 20. Okay, now what do we need? The question is, what is the largest possible volume? So it's not looking for the largest possible base. We need to actually figure out the max volume now. So we need to figure out our y so we can get our volume. Do we have an equation for y? Yes, we do. Yeah, we could do that too. Oh, that's even better. This one? Yeah, let's do that. Great idea. Save us. Okay, so we could solve for y to get volume, right? Or we already have an equation for volume just in terms of x. So why not use that guy instead of having to solve for y and then get, yeah, as long as that equation is correct. So our volume would then be 900 times 20√3 minus 1/4 20√3 cubed. We have to simplify this. Well, it doesn't say it's an exact. Okay, let's just plug that in. I will tell you if I want an exact value. If I want an exact value, then we need to keep our roots. Let's do to the nearest tenth. So what is the max volume going to be then? To the nearest tenth. So when that's any different? Yeah. Yeah. 6.1. Yeah. Yeah. So that in units here would be centimeters cubed. So the largest, therefore, the largest. And on your unit exam, most likely I'll just say to the nearest tenth. I know you're dealing, like, exact values can be difficult sometimes, especially when it's something like this, like a cubic of a square root. It's not horrible, but it's not the greatest. So the largest volume would be that. So really the same as last day, right? Like, not much different, just more algebra. A little bit more algebra. I like this problem. A right circular cylinder has to be designed to fit inside a sphere that is 6 meters in diameter so that each of the corners touches the circular edge of the sphere. We say that the cylinder is inscribed in the sphere. Find the exact value, or the exact dimension, of the cylinder with maximum volume. Okay, well, okay, so what are we trying to maximize? The volume of the cylinder. So what is the formula for volume of a cylinder? V equals pi r squared height. Okay, now we only need one variable, so I'm going to pause it here. We need to find a relationship between what two variables then? R and H. So there has to be a relationship between our radius and our height. So I would like you to see if you can figure it out. And I'm going to pause. Record. So, so half the radius, yeah, so then you would end up doing the same thing in the end. Yeah. Okay, so let's make a so we have half the height here, a radius of the cylinder, and then our radius of the sphere, which was 3. Okay, so how can we relate them now? Pythagorean, so 3 squared or 9 equals h over 2 squared plus r squared. Now we have to replace one of these variables here. Which one would be the easiest? R. We can actually even write it as r squared equals. And just replace r squared. Ooh. Okay. So r squared is equal to 9 minus h squared over 4. I brought in the square. Why square root something and then you're just going to square it again? Exactly. Waste of time. What?
I don't understand where you got the 9 equals h over 2.
Oh, so Pythagorean of this guy.
Oh.
Okay, so now let's replace r squared. So pi times 9 minus h squared over 4 times h. Okay, do you want to try and solve the rest from here yourself?
Yeah.
Okay, I'll pause it. See?
I'm not taking.
Okay. I'll show you how much time it takes, okay? 9 pi h minus h cubed, or pi over 4 h cubed.
You know how much time it takes to like.
So here, with respect to h, would be just 9 pi. Derivative of h is 1 with respect to h, minus 3 pi over 4 h squared. Okay? So, what are we setting to 0? The v, dv dh. Now, we want to factor this. And we can factor 3 over 4 out. We want to make this a fraction. To make it, well, I guess you don't have to, but we are trying to we can also add this to the other side. Is that what you guys did? Some of you? We're solving for h. Yeah, so you added this to the other side. Good. So 3 or h. Cancel out the pi's. Okay, so now I have 3 over 4 h squared equals 9. So 9 times 4 thirds is 3 times 4 is 12. So square root of 12. Well, we can go 3 times 4, so 2 root 3. 2 root 3 is our height. Now it says find the exact dimensions. So we know the height. Now what do we need? The dimensions of our cylinder. The radius. Do we have a formula for our radius? Yeah? What's our formula? Beautiful. Okay. So r squared equals 9 minus 2 root 3 squared over 4. Row 12. Yeah, because root 12 squared is going to give you 12 over 4, or 3, and 9 minus 3, 6. Our radius is root 6. And the maximum volume, then? Pi r squared. So r squared, root 6 squared is just 6. And the height is 2 root 3. So it'd be 12 pi root 3. Would be our max volume. With dimensions, with height, 2 root 3. What's the units? I should have put that in there. Meters. So this is meters cubed. Meters, and radius, root 6 meters. Are we okay? Okay. So once were you good up to where we got our height? And it said find the max dimensions and volume for a situation. So now we have our height. We could figure out our radius, given that relationship we found. And then our volume is equal to pi r squared h. So we just, given now that we know our radius and height, plug those in. We get the max volume. There's a question like this, I think, on your, kind of similar to this, on your assignment. Yeah, and you're going to kind of set it up very similar to this idea. And you have to find that relationship inside. Same idea. Okay. All right. One more question. Who thought 3 questions could take so long, hey? Okay, ready? Are we almost done? Okay. Well, speaking of hard, our next question. All right, next question. Last question. A 1.5 meter fence stands on a ground and runs parallel to a tall building. Okay? If the fence is 4 meters from the foot of the building, find the shortest ladder that will extend from the ground over the fence to the wall of the building. Determine 2 centimeter places. Okay, so we want the shortest ladder. And we could do it like this, right?
It doesn't say that the ladder has to be straight.
You can do this. It's a straight ladder, okay? It's an assumption that we make.
Although it could be one of those ladders with like
Dangerous.
extra feet, and then you could be like
No, okay, it's a straight ladder.
How big is this building?
Doesn't matter. It's infinitely big. Okay? Okay? So question is, what are we trying to maximize?
6 meter pole man.
Or minimize. Sorry, in this case, minimize. The hypotenuse. Ooh, good word. Hypotenuse. We need a formula that has that in that, the hypotenuse. Okay? It actually is a little bit similar. We're trying to minimize the hypotenuse. So in order to get a formula for hypotenuse, we need to relate the base, right, the horizontal with the vertical. Okay, so this amount can change right here, right? Can change. So what are we going to call this portion right here?
X.
Sure, beautiful, love it. Okay, now I'm going to let's draw this this horizontal line here. So you can split it up into those two triangles. We know that these angles are the same here, right? Which is also a similar triangle with the big one too. We have three similar triangles here. So what are we going to call this area here? Because we know this is 1.5. Let's call it y. I like x's and y's. I don't know. It might be a bias because of my love of math. Okay, so now can we relate the hypotenuse? What do you want to call the hypotenuse? Z? C? Sure. C. Smiley face. You can go ahead and use smiley face. But I don't know, and then you have to write D smiley face D something after. Okay, so can we make a relation? Can we make the formula now for our hypotenuse? C squared equals equals what? X plus 4 squared. Oops, bracket. Plus y plus 1.5 squared. Okay. Now, we need to get rid of a variable. So somehow we need to relate x and y through similar triangles. Okay, so similar triangles. What are the similar triangles we can use? X over 1.5 equals 4 over y. Okay, you want to go back to just similar triangles? Okay, we're not done. So we want to replace one of these, either x or y. It doesn't matter which one. So we have x over 1.5 is 4 over y. Similar triangles. Or, yeah, y over 4 equals 1.5 over x.
Or 1.5 squared plus x.
Or you can go x over 1.5 equals 4 over y. Oh, we did that. Solve for x, sure. It doesn't matter which one. Either x or y. Whoever's easiest, maybe x. It's already on the numerator. So if we multiply 1.5 up, that gives you what? 6 over y. I'm going to change that to this for the sake of, for the sake of derivatives. Well, you would have. You know why? We're going to go sub this back in, and you're going to have to do derivative of this. And then you'll be like, oh, I have to think, yeah, exactly. I have to bring it up. So x becomes 6y to the negative 1 plus 4 plus y plus 1.5 squared. So this guy, which would have been 6 over y, you're going to have to derive him. So you would have brought him up. Already ready to derive this. Well, because the negative exponent, really, like, simplifying this is not going to do us much good. Let's just go straight to deriving. Chain rule. Yeah, chain rule. So derivative of c squared. 2c times bcd. Everything's with respect to y. Okay. Okay, how do we derive this guy? So before chain rules, and within the chain rule, we're going to use power. Okay, so bring down the 2, leave the inside. Minus 1 times the derivative of the inside is to the power of negative 6 power of y to the power of negative 2. Right? Because you subtract 1. So negative 1 times 6, and then subtract 1 gives you negative 2. Plus derivative of the other guy, bring down the 2, leave the inside. Subtract 1 is just 1. Derivative of the inside, 1. So we're good. Whew, he's ugly. Okay, how can we simplify this? We can cancel out the 2's if you want to. because there's a 2 in everybody. So let's get rid of that. And make who 0? Because we're minimizing who? dc dy is 0. So we just get 0 equals. Now, do you want to start to bring in this guy? Or is that too much at once?
Yeah, I say do it. Do it.
Okay, can I bring this in? Yeah? So 6 times negative 6? Negative 36. Y to that? Negative 3. 4 times... Okay? Minus 24. Y to the negative 2. Plus y plus 1 1/2. Or 3 over... We're going to do that 3 over 2. Oh, this is going to be fun to solve for y here. Okay, how are we going to solve for y here? Bring it down? Yeah, factor out, or either you're factoring out y to the negative 3, and we can factor out.
No, you can't factor y to negative 3.
Why? It's the lowest power. That's okay. It's because it becomes y cubed. Remember, this is what we did before. It's y to the 0 right now. So 0 minus negative 3 gives us positive 3. It's the same thing as getting a common denominator. Right? It's the exact same thing as getting a common denominator. Because if we brought this to y cubed on the bottom, this y squared on the bottom, the common denominator would be y cubed. This guy would need a y on top, y squared, y cubed. Okay? Now we also want to get rid of the fraction. What makes more sense to you, factoring or common denominator?
Factoring.
Factor, okay. Doesn't matter. Really doesn't matter. So factoring, let's go like this. Let's get positive exponents. I'll show you common denominator. Y squared plus y plus 3 over 2. Okay, so common denominator would be what? 2y3. 2y3. So this becomes negative 36 times 2, negative 72. This becomes, times this by 2y, minus 48y, times by 2y squared, plus 2y squared. It's the same, you get the same thing if you factored out. And then plus, this already has a 2, y cubed. Which one? This one, because these coefficients 1. And if you want to make a common denominator of 2y cubed, what's missing from, so if you want this to be 2y cubed, you have to times the top by 2y squared. So top and, sorry, what you do, I'm confusing myself. You need a common denominator of y cubed, so you have to multiply top and bottom by 2y squared. Oh, yes. Why?
You don't need multiple another y.
Because it has the bottom is 1 right now.
I know. Why in my head? I'm used to factoring is so much easier.
I did factoring, I'm sorry.
Why 4?
Yeah. Because you're timesing it by y to the 3.
Oh, yeah. Okay. Yeah, you're right. Sorry. Thank you. And plus, okay. This is really ugly, but that's okay. Okay, I'm going to multiply this up, so this can be gone. Right? Because we have 0 on the other side. Now, when we have 4 terms, often we use, we can use what? What? Grouping. I'm going to reorder this. Okay, what can you factor out of the first two? A y squared? Just highest degree to lowest. Thank you. So you can take out 3 y's. Thank you. No, it's just because. Uh-oh. No. Okay, it's not. I'm so used to factoring the common denominators. It threw me off. Okay, so we're left with 2y plus 3. What can we factor out of those two? Minus 24. So it becomes 2y plus 3, which gives us 2y plus 3 and y cubed minus 24. All right. So that means y is either negative 3 over 2. Is that possible?
Why not?
It's a negative value for y. Can't have a negative.
Wait, so we can have a
It's a-
negative ladder? Half-high
Oh,
ladder?
the ladder was just the answer.
No, because it's 1.5, and this is then it'd be. Okay, no. So here y cubed minus 24 has to equal to 0. So y cubed equals 24.
Oh, yeah, I see how that works.
Cube root of 24, 8 times 3. So it becomes 2 cubic root 3. Let me cube root that. Okay, so which is approximately, because it says 2 decimal places.
What is that?
What?
Just this. Otherwise, people will be like,
Approximately?
oh, we're not done.
This? Or
No,
this?
just for y.
Wait, the thing beside it.
That dot line, that's a C.
Dot line dash.
Only counts on y.
Okay.
Just get x.
Do you want to we can just plug it into the original.
We actually want to know if that
Okay.
works.
Okay, so the question is, what's the smallest ladder? So we need to find our C value. No,
Yeah, it would have just been lower than the original.
it's not possible. Look at the drawing. Okay, if this was negative 1.5, this would be 0.
This is where we need a
This is negative a half. You can't have a negative half distance. Distance cannot be negative, period.
Well, wait though. It would, I believe,
Okay.
satisfy all the...
Okay, so we need to get this done so we can actually have time for homework today and studying in your assignment. So our equation for C is right here in terms of y. And that's what we need to find out. Okay, so let's plug it in. So C squared equals, guys, 6 over y plus 4 squared plus y plus 1.5 squared. And our y value was what? It was root 24, or 2 cubic root 3, or cubic root of 24. So this you can just plug into your calculator, so it says 2 decimal places. Cubic root 3.
Why did you just make up? It's a 6. No, it's B. I lied. No,
A B? 6.
No, it is a 6.
6.
Okay.
I thought it was a b.
Right? From your original equation? It's okay, you can insult it. This means I need to improve my writing. All right, so tell me what that is. What other way? You could also just figure out what x is as a decimal, y is a decimal in, x, right? And then plug it into this guy. Oh, to this step? Sure, I'll show you in a second. It should be 7. So squeegee square root it. And then square root. So 7.49. Anyone get 7.49? What? 7.5. 2 decimal places. Did you keep it as exact? Okay, as an exact value. Okay, so it would be 7.50 meters. Meters is the smallest ladder. Okay, this step here, see if I can select it. Oh, no, right here. Copy, paste. So when we were factoring this, oh, it was before that. When we were at 36 y cubed, what? Minus 24 y to negative 2 plus y plus 3 over 2. So we always want to, so what I would want to factor out is the smallest power is y to the negative 3, right? So if you factor out y to the negative 3 first, this becomes negative 36 minus 24, just 1y, plus y to the 4 plus 3 over 2y cubed. Okay, then I would times so this, there's 0 equal here, right? So I could bring this to the other side, gone, and then still factor out the half. Right? Okay, so now factor out the half means that everything would double because we want to get rid of our fraction. 48 y plus 2y to the 4 plus 3y cubed. Okay, so then this, you can times 2 up, right? Times y cubed up, it's gone because of the 0. And then just factor this guy instead of getting a common denominator. It's really the same thing. Okay, all right, I have to find this. I have it somewhere. So for now, 14, 17, and 20, the worksheet's just extra practice. So I'll get it for you. I know a lot of you need to start your assignments. Get working on that, right? And you have the practice exams. The solutions are online for the practice exam.